absolute value function, and function containing radicals, and sketch diagrams. So we are starting with the definition. So I should have asked you to give me the definition of set, but unfortunately I've already opened it. So what is a set? A set is a well-defined collection of distinct objects. Well-defined collection of distinct objects. So we've been using sets in our daily language or something like that. So I'm buying saucepan sets. We go to the market, say I'm buying saucepan, I want the set. I'm buying this, I want the set. So the set is a well-defined collection of distinct objects. So the objects are distinct. Now, objects in the set are called its elements. Am I online? I'm online. So when we take each of the objects in the set, we call it the element or member of the set. So example, if I have a set A, please, can you see my board?
Yes, Doc.
Yes, madam. Yes, madam, please.
Okay, so if I have the set A, which contains 1, 2, 3, 4, 5, each of the objects here, 1, 2, or 3, or 4, or 5, we call them the elements of the set A, or members of the set B. Now, if I take the set B, I have A, B, C, D, E, F. Okay, A, B, C, D, E, G, H. Okay. Now, if I take A, I call A the element or member of the set B. It says that where A is called the set and A, small a, Y, G are called the elements of the sets. Okay. So mostly we use the capital letters to denote the set and the small letters to denote the members in the set. Okay. Now, if mathematically you want to write that A is in, small a is in B. Okay. So as I was saying, I said that I have the set A, and then it contains 1, 2, 3, up to 5. Okay, so let me just add 4 and 5. Now, if I want to write that the element A is in the set B, I will use this notation. So I'll write that the 1 is in the set A, and it is, we call it belong to. So we say that 1 belongs to A. I hope you remember this.
Yes, madam.
Do you remember this? Okay.
Yes, madam.
So we belongs to. So I will write 1 belongs to A. And if it does not belong to, if it's not a member, we can see that there is no alphabet here. So I can write that small a is not a member, or it does not belong to big set A. So this one is belong to, this is does not belong to. Then we have different ways of representing sets. You have the roster method and other things. Okay, so we can have something like this. Maybe A is equal to, then you list all the elements, or you can have a mathematical expression for that. A is equal to X such that X is an even number. So even number, it means that I'm starting from 2, 4, 6, 8, and others. You can also have something like this. X belongs to U, where U is the universal set. You know what a universal is. So universal. Then you defined it by using expression. So x squared minus 2s plus 2 minus 3s plus 2 is equal to 0. So this means that I have to solve this quadratic equation. You know how to solve a quadratic equation. When you solve this quadratic equation, you're going to get 1 and 2. So it means that the elements in this set are 1 and 2. Okay, so that's ways of representing sets. Then when you take a set, we have what we call empty sets. Empty sets. So a set which has no element is called an empty set or a null set. Hey, someone is, who is that? Please mute your Angie.
Sarah. Okay.
Madam Angela.
Okay. So a set which has no element is called an empty set or a null set, and it is not denoted by this or this. So that's an empty set. Then we have what we call unit sets. So a set which contains only one element, units, is called a unit set. Or a singleton. So unit set or a singleton is a set that contains only one element. Then we have what we call universal sets. So universal, when we talk about universal, the universe, so it means that everything inclusive. Okay. So the set of all elements under consideration is the universal set. Universal. And we normally denote the universal set by some, you see mu or u. Mu or u, big U. That is the universal set. Any question before I continue? Please, you have any question for me?
No, madam. No, please.
Madam, you can continue. No.
No, madam, please, I'm not seeing your screen.
Do you all, are you all seeing my screen or you are not seeing my screen?
Please, we can see your screen.
It's now appear.
So
Then we
please
can
share.
see. Maybe it is.
We can see your screen,
Network.
madam.
You can
It's
see.
inside.
Yeah, so that's your network. Please check. Okay. Then when we come to sets, we have what we call equivalent sets. Equivalence. So the things here are just English. When we say two things are equivalent, it means that they have an equal number of elements. Okay, the elements in them are equal. One number. We are talking about a number. Okay, so I can have a set A, and it has 1, 2, 3. And then I have the set B, and then it has the set A, B, C. I can say that they're equivalent because the number of elements in A is number of elements in A. Okay. Please, I'm coming on. The number of elements in this is 3, and the number of elements in B is also 3. Okay, so let's continue. It says that an equivalent set, a set with an equal number of elements is called an equivalent set. Okay, so they have equal number of elements, so they're equivalent sets. Then we have what we call equal sets. Equal, when you talk about equal, it means that they are the same. So two or more sets are said to be equal if they have the same elements. So if I have a set M that has members A, B, C, and the set N has CAB. Okay, you can see that the elements in this are the same as the elements in this. So it means that they are equal sets. So we write it as M is equal to B. Okay. So when we talk about a set, two sets being equal, it means that when I pick the sets M, you see that the set M is contained. When we talk about contain, it's a net contain. It's contained in the set M. All the elements in M can be found in N, and all the elements in N can be found in M. Okay, so if I have two sets, A, and it has the members A, B, C, and the set B with the members C, A, B. You can see that every member in A is a member of B. So I can say that my A is contained in B. And then every member of B is also a member of A. So I can say that B is also contained in A. So now if my A is contained in B and my B is also contained in A, then I can conclude that my A is equal to B. So if my A is contained in B and B is contained in A, then I conclude that they are equal sets. Can I continue?
Yes, please.
Then what we have, what we call subset, sub, English sub. We have a set and a sub. So we have subgroup, subverse. Okay. So if I have a set and I have a subset, it means that I have a bigger set and then we have small set under it. So a set A is called a subset of a set B if every member of A is a member of B. Okay. So let me just write this. So I have a set A. It contains 1, 2, 3, 4, 5. Then I have a set B and it contains 2, 3. Okay, so something like this. I can say that B is a subset of A because every member of B is in A. Can you see that?
Yes, please.
Mhm. So every member of B is in A. So it means that my B is a subset of A. Okay, so it says that a set A is called a subset of a set B if every member of A is a member of B, and we write it as this. Then you have some symbol, then you have underline it. So this one, this is different. This is A is rather a subset. But for our example, it was B a subset of A. So maybe if for this definition, I'll have to clean this. So this is my B and this is my A. Then I'll say that A is a subset of B. A is a subset of B. It's the same thing. The most important thing is for you to understand it. Okay. So if A is a subset of B and A is not equal to B, then we say that A is a proper subset of B, and we write it as that. Okay, Yakubu.
Madam, the symbol of equal set and the subset, are they the same?
Equal set.
Yes, the symbol in between them.
Equal set, we use equal to. Equal set, we
Okay.
use equal to. So if two sets are equal, we write it as that. But what I said is, if two sets are equal, then it means that If A is equal to B, then it means that my A is contained in B and my B is also contained in A. So if A is equal to B, then it means that A is a subset of B and B is also a subset of A. If A is a subset of B and B is also a subset of A, then I can say that they are equal sets. So this symbol means that a subset. Okay, subset. Okay. So when we take our example, we can see that there are some elements in B that are not in A. In that case, it means that the set, yeah, okay. So it's in this case, it means that our set A is smaller than the set B. Okay. So this case, we write it as A. Then we write this without the that underlined this line. Okay. And we say that A is a proper subset. Proper subset. So this symbol looks like the less than and greater than that we know in equality and inequality. Okay. So if we have this without the line under it, then it means that this set is smaller than this set. So it says that a set A is called a subset of a set B if every member of A is a member of B. And we write it as this. If A is a subset of B and A and B are not the same, they are not equal, then we say that A is a proper subset of B and we write it as this. And we have what we call complement sets. So a complement of a set A is the set of all elements not in A. So when I take two sets, okay, then when I talk about the complement of the sets, okay, and I'm talking about the members that are not in the, so let's take even our A and B. A and B, we can see that B is this and then A is this, okay. So when I talk about the complement of the set A complement, we can write it as this. This one, we are talking about elements that are in B, but not in A. Can you give me that element, those elements, the elements that are in B, but not in A?
1 and 5.
1,
5.
1 and 5. So that is the complement of A. So elements that are in B, but not in A, that is a complement. Okay. Let's see. So a complement of a set is the set of all elements not in A. If A is contained in S, a complement of the set of all elements which are not in S but not that which are in S but not in A, and denoted by, okay, so the complement, you can have it as this. So sometimes you see it as this or this. It all denotes complements. Okay. So for my A and B, the elements that are not in A, that is my complement. And then when we use the Venn diagram, if I have a set A like this, then the complements are the members outside my A. So we are looking at an example. If A is A, B, C, D, E, and my B is A, B, C, D, E, F, then my A complements are elements that are not in A, and we can see them as F and G. Can I continue?
Yes, please.
Madam.
Yes, madam.
Then, so we have looked at some definitions. Now I want to look at operations on sets. So now you know what a union set is. Universal set, equal sets, equivalent sets, unit sets, empty sets, and others. We want to look at operations on sets. Okay, so there's a hand up. Your name there, I cannot mention it too.
I want to find out if the recording is on because so as me.
Yes, please, it's on.
Some of you are not paying attention, so you will need the recording. Is that what you want to tell me?
Oh, no, not really, but maybe something can interrupt him.
I hear, thank you. So let's continue. Okay. So we are on the operations, and on the operation, the first thing that we'll talk about the intersection of a set. Have you heard about intersection of a set before?
Yes, please.
Yes, please. Yes, please.
Can you tell me something more about the intersection of a set?
Okay. Madam.
Yes.
Okay, the intersection of a set is a type of set that if you can find either a variable and number, the same variable and number in the two sets
Okay,
or three sets.
please use two sets. Let's have the
Okay.
set A and B.
Okay,
So you can use
for example,
examples.
okay, so set A and set B. If you can find a variable in set A and the same time in set B, so that one become intersection. For example, if set A is 1, 2, 3, 4, and set B is 1, 7, 8, 9, means that the intersection become 1 because you can find 1 in set A and 1 in set B. Thank you.
Thank you very much, Jeremiah. Thank you. So there's a hand up, Yakubu, Dean.
Madam, please, is the portion that is shared, the portion that is shared between two sets?
Is there
The portion that is shared between two sets.
okay? So you are talking about Venn diagram, right?
Yeah. Yes, I'm talking
So
about
when
Venn diagram.
you have Venn diagram and then the portion that is shared between the two sets, that is your intersection. Thank you
Yeah.
very much, Yakubu. Thank you. Any other? I can see another hand. Sulim Laba, you have something for us?
Yes, madam.
Okay.
Please, the intersection of two sets are elements that are common to both sets.
Okay. So when I have two sets, the elements that are common to both sets is the intersection. Thank you, madam. And there's another hand. Agosa, Christian.
Yes, madam. Please, I'm
Mhm.
sorry, and maybe I'm taking you back small. About the compliment you mentioned earlier. I'm sorry if I'm taking you back.
No problem.
The complement. I realized I saw E and B, and I wanted to ask if the complements are members that are not found in E, but are in the universal set, or
Yes.
is a complement of E.
So
Madam,
this
please,
one I gave two sets. This one I gave two sets as A and B. And A and B, we saw our B as the bigger set, that's the universal set, or the bigger set. So we are comparing these two sets. So the elements that are in B but not in A, that was our complement sets.
So it can be the case that if
I give you two
sets are,
sets, if I give you two sets, then the sets that are in B but not in A, that is a complement of B.
oh, okay,
Yeah, complement of A.
I thought it's always coming from the universal set.
Okay, so in this case, I gave you only two sets, so it means that my universal set will be my bigger set. Do you understand?
So if the question comes and even they didn't say that the B is the universal set, but
this
the B has.
Which one will be your universal? If I have A to B, A, B, C,
Please, madam,
and
I
then
can't
my
see the
B,
screen. Oh.
so it's coming from your end. If I have A to be A, B, C, and then my B to be A, B, C, D, E, F, what will be your universal set? So here you are comparing the two sets. Eh? It is these two sets that we're talking about. So it means that
Okay.
since I've given you two sets, it means that your universal set will be the set B.
Okay. Okay. Thank you.
You're welcome. Okay, so you are all correct. So it says that if I have let A and B be any two sets, then the intersection of the sets A and B written as A, then you have this symbol, it looks like N, B, is a set of elements that belongs to both A and B. So what you said is correct. The element that can be found in both A and B is the intersection of the two sets. Okay. So we can write it as A intersection B is equal to S such that S is in A and X is in B. So we use AND to represent intersection. Okay. We use AND to represent intersection. So the one who gave us the definition for the Venn diagram, you can see that you have this set and then this set too. So my complement is the area, this shaded area. That is the element shared by the two of them. That is the intersection. Okay, then maybe you give me the definition for the union. Okay, so what's the union of a set? Yeah, Elizabeth.
Yes, madam. Please, the union of a set is the combination of both sets. It's like putting two sets together.
Okay, so putting the element in both A and B. Thank you. And then move back. Your hand is up.
Madam, it's Mubarak.
Mubarak, but you didn't complete it.
Yes.
And
You said?
Mubarak, yeah, it's Mubarak, yeah, Mubarak. Your hand is up.
Okay. Yes, please. Universal set is the mother set of all sets. Assuming we have set A, B.
This we are talking about. We are talking
The
about.
member.
No, we are talking about union.
Okay. It's the combination of two sets, putting the values together, or the elements
So
of both sets together becomes the union of the sets.
what about if there are three sets?
The same thing when we put all the three sets together, the elements in all the sets together.
Thank you very much, Mubarak. Foster 2 is on. Chairman, your hand is up.
Madam,
Chairman Foster.
Madam, the union, as my colleagues have already stated, is a list of both sets that are in recognition, where an element is set not to be repeated. If it appears in both sets, you write one. Thank you.
If it's in what?
I said,
You said something. If it's
yeah. I said that
if
if
it's in,
a particular element, repeats itself in all the sets, you write one.
Thank you.
Yes.
So I was going to give you an example where I will have an element in both sets and see if you're going to write both of them. You're going to repeat the element or you write it one. Thank you very much. But what about, have you heard of disjoint sets before? Disjoint sets. And now English, disjoint. Have you heard that one before?
Yes, please.
Okay. So what is it? So Spencer, your hand is on a Dawson. My people are good though. Okay, Spencer first. Gifty, what's a disjoint set? Okay, Spencer, please say.
So that's the situation whereby the elements given, they don't have anything in common. No element is found in each, so they can't intersect.
Okay, thank you, madam. Spencer, is it Spencer or Gifty? Okay, Spencer.
Please, I've talked
John.
already.
Okay.
I'm the one who explained right now.
Okay. John, we are listening.
Okay, when two or more sets have nothing in common, they are said to be disjoint. They don't have any element
So
in
joint
common.
any member in common. Yeah, they are disjoints. Okay, thank you very much. Okay. So let's look at what I have here. If two sets A and B have no elements in common, then A and B are said to be disjoint. So what will be their intersection?
Now.
So if I have two sets, now
Empty
sets.
set.
Okay, thank you very much. Okay, and now sets. Okay. So if A and B are disjoint, then it means their intersection is a null set. So I have this set and then this set. Their intersection is a null set. Okay. Now, if A is contained in B, if A is a proper subset of B, then their intersection will be the set A. I hope you get it. So if I have these, okay, so when we consider the two sets A and B, this sets A and B, you can see that all the elements in A can be found in B, and A is a proper subset of B. So in this case, my intersection will be the set A. So you mentioned union of a set. Now the union of two sets denoted by this, so you can see something like U. Okay, so that the union is a set of elements which belong to either A or B. So please, for union, we use all. Okay, so either A or B or both A and B. So the mathematical expression A union B is equal to S such that X is in A or X is in B, or X is in the universal set such that X is in A or X is in B. So that is it. So if I have these two sets, then the whole shaded area will be my union sets. So let's look at this one too. It says that if A and B are finite sets, you know what finite is? They are finite sets. Okay. Then the number of elements in A union B, the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A union B. So that is that. So let's see. What we are saying is if A and B are finite sets, what is happening? My internet, my this thing is not responding. So I have A. Oof. I have my A to be 1, 2, 3, 4. And I have my B to be 1, 2. So that's a finite set. Okay. What's the number of elements in A? The number of elements in A is what?
Yeah, 4.
And then what about the number of elements in B?
2.
2. It says that if A and B are finite sets, then the intersection. Okay, so let's find the union, A union B. What is A union B? Let's find A union B.
1, 2, 3, 4.
1, 2, 3, 4.
Let's find A intersection B.
1,
1,
3.
3.
1, 3.
1, 3. Okay. So can we find the number of
1, 3.
elements in A union B? What's the number of elements in A union B?
There are 4.
And the number of elements in A intersection B?
2.
There are 2.
So from that expression over there, it says that if A and B are finite sets, then the number of elements in A union B is equal to number of elements in A plus the number of elements in B minus the number of elements in A intersection B. So please, let's solve the right-hand side and see. We said the number of elements in A are
4.
and the number of elements in B are
4. 2.
B, there are 2.
and the number of elements in their intersection
That's
Also
is
2.
the intersection of A and B is
4.
So this one give me what?
It's
4.
2.
Okay. Okay. Then we also saw that the number of elements in A intersection union B is also 4, right? So we can have 4 is equal to 4. So this is correct. It says that if they are finite, then the number of elements in A union B is equal to the elements in A plus the elements in B minus the elements in their intersection. Then if they are disjoint, then the number of elements in their union is equal to the elements in A plus the elements in B. So you can pick 2 elements, maybe one with numbers and the other one with alphabets. And then you see that their union, the number of elements in their union will be the same as the number of elements in the individual sets. Okay. Now, if A is a proper subset of B, then my A union B will be my B. Okay, so you can pick 2 sets, a set A and a set B. Maybe B is A, B, C, D, E, F. And then your A will be A, B, C, D. Then you find the union. You see that the union will be all the members in B. Okay, so you're going to have it like that. Okay. Any question? Any question? Any
No,
question?
madam.
No, madam. No, madam.
Mubarak.
Madam, with the proper subset, please can you illustrate an example for us to see?
I did, but maybe you were not paying attention. So next time you have to pay attention. Mubarak.
Thank you, madam.
So I'm going to give you an example. So I have a set A. And I have a set B. Now we can say that A, B is contained in A. All the elements, this one means contained. Okay. But you can see that for this one, all the elements in this is in this, and even it is less than this. Okay, so definition says that It says that if A is contained in B and A is not equal to B, then we say that A is a proper subset. So we can see that B is in A and my B is not equal to my B is not equal to A. So it means that my B is a proper subset of A. So I said that this one looks like the equal, less than and then greater than that we know. So it's a proper subset. So all the elements are in here. It's a proper, and they are not the same. So it's a proper subset. Mubarak, are you okay?
Yes, madam. Thank you.
You're welcome. Let me see. I'm not well. Since yesterday, I've been running, sir. So maybe I will end somewhere and then we'll look for another time and meet, okay?
Sorry, madam. Please recap.
But madam, we are
I said,
enjoying your
I said,
lesson.
Oh, madam, sorry. Oh.
I'm not feeling. I'm supposed to meet you today. That's why I have
You'll
to
be
come.
fine.
That's why I hear. So let's just do difference of a set. Then maybe we'll look for another time and meet because I'm not well, cry. Okay, so the next thing we want to look at is difference of a set. Okay. So given that A and B are subsets of U, you know U is the U or mu is the universal set. So I have a universal set, then I have two sets A and B. They are also in U. Now the difference of the sets A and B denoted by this, so difference we write it like this, is a set of elements in A which do not belong to B. So we have two sets A and B. So let's assume I have the set A and then the set B. Now, when I talk about the difference of A and B, we are talking about the elements in A which are not in B. The elements in A which are not in B. So we write it as mathematically A difference B is equal to S such that S is in A and S is not in B. Or is the same as A intersection B complement. So let's look at this example. So I have the set A, the A is 1, 2, 3, 4, 5. And then I have the set B, B is 1, 3, 5, 7, 9. Now A difference B, we are talking about the element that are in A, but not in B. So taking this, you can see that we have 2 here, there's no 2 here. We have 4 here, there's no 4 here. So the A difference B are elements in A, but not in B. Do you get it?
Yes.
Hello?
Yes,
Okay.
madam.
Then we can also talk about B difference A. When we talk about B difference A, we are talking about elements that are in B, but not in A. So when we come here, we can see that we have some members which are in B, but not in A, and they are 7 and 9. We don't have 7 and 9 here. So the focus is on B, the elements in B which are not in A. That is my difference. Let's see, I think there's a hand up. Okay, Michael.
Madam, does it mean always the two sets must be equivalent?
No. They are not supposed to be equivalent, but just that you are looking at elements that are in A but not in B. So if I have two sets like this one are they equivalent? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, okay. Please no. So I can even have this to be 1, 3, 5, 7 without the 9. Then B difference A will be only 7. That is if I don't have the 9. So they are not equivalent, but I'm talking about elements in B that are not in A. Are you
So
okay?
by comparison, you just have to compare the elements that are not in A and the elements that are not in B. So the opposite will be the X. Okay, I understand.
Yes, sir.
Thank you.
Any question? You're welcome. So when you take the diagram like this, then my A difference B will be the sets. So you have the intersection. We are looking about elements that are in only A. Okay, so code. Okay, Michael, your hand is up again.
Yeah, looking at the A difference B, can we also say that the A difference B is the same as B complement?
So A intersection, A difference B is the same as A intersection B complement.
B complement.
A intersection B complement.
And
Yes,
B
please. And then B difference A will be A complement intersection B.
Okay. Thank you.
Okay. Please, who is my monitor here? Code monitor. Is my monitor here? Code monitor.
you know there.
No, the monitor from code. Okay, so
Course
please. No, not even the course rep. Please, as I said, I'm not feeling
Madam,
well. So
Madam, I don't think the person is here.
When we started, he
thank
was
you.
with us.
Okay. So as I said, I'm not feeling well. So please, let's look for another time and meet, or maybe we meet next week and then we decide when we meet again. Okay.
Please, madam, we will need the slides. So
yeah, I'll share it with you. So I don't know if you can create a platform, or maybe the course rep will contact me, then I share the slides with you.
Okay.
Madam, you have a platform.
So madam, we are going to meet on next week.
Yeah. Or maybe we will. So when you add me to the platform, then we'll decide maybe if you can look for another time.
Right, tomorrow we'll be able to meet us, madam.
Tomorrow we have 102. Is it the same group?
Yes, madam. Yeah.
So just pray for me so that I get well. but I will definitely meet. What time are we meeting?
In the morning.
In the morning, what time?
Eleven
Is it still
11:30.
Hello, madam.
Okay. Yes, yeah. Thank you, Mubarak.
Madam, please, we have a lesson.
You have what?
Tomorrow, God willing, you have 2 lessons. Advanced algebra and calculus, as well as.
Yeah, I will take you analytic geometry and calculus. That's what I will teach tomorrow.
Yes. Yeah, that's what we have at 11:30 to, I think, 3:30 or so. Yeah.
Okay. All right.
Okay,
Thank you, madam.
Thank you very much. So,
Madam, please take care of the statistics.
I have no idea. So please add me to the group and then
Madam,
let's
madam, please,
will meet.
I have a question. I think all the members on this platform consist of both those majoring in mathematics and those having maths and ICT. And even with the maths and ICT, we have different centers, and each center has its own class rep. So the class rep they said is on this platform is maybe for a certain group. And so I suggest that we should create a general platform for this very
group
course, so that we will all be on it, so that whenever any we think.
Okay, so please do that for me.
You already have the
thank you
platform,
very much.
So it's a matter of you joining the platform that already exists.
So please send
Which
us the link.
platform are you talking about? Is it on Discord?
So why are you talking about this again? Because the course reps.
So please try and share the link.
It's okay. It's okay.
Please,
Madam is not feeling
please
well.
let's end there.
It's
Let's
okay. Let's
thank
leave
you very
Madam.
much.
It's
Thank you
okay.
very much.
Madam, please go and rest. You are sick.
Okay, bye-bye.
Bye, madam.
Bye, madam. Have a nice day. You boys can talk, oh.
Please, the
You boys
course
can talk, oh. Platform to you
What's
all
the
argue for
platform are
here.
you talking about? We have math students,
Platform to you all argue
those who
for
are
here.
please, the course
specifically
rep.
majoring in
Please
math. So
kindly
the
send me
platform we are
the
talking
link.
about, are they on it? So we need to create a platform for this very course. That's all.
No, we have a platform already.
Charlie,
We have a platform.
platform no.
Which
Doesn't
platform?
matter
What
of
is the name
having a
of the
platform
platform?
already. Some of
Platform
us
no
are
on unim. It's no say. And also I get a link, no. I feel na say a group for. Ah.
No, what is the name of the platform? What
I keep the
platform?
phone. I'm on the page. Someone made it.
Please
Ah,
send the link for us to join.
This
You are
is not
talking
a matter
about you having
of
a
Okay,
platform.
you
You
will
have
send
a.
it to you.
How can you
Mike.
know you have a
We need
platform?
to
And
come to
how do
an
we join?
agreement.
Hello.
So just
Please,
take your
please,
time.
you are
Let's
not
come
on
to
the
an agreement.
platform. Drop your
It's not
number.
it's not a matter of fight.
Please, if you are not on the platform, drop your number here and I'll add you.
No.
Okay.
Okay.
Just share it to the other groups. Share the link.
Hello. Please that number is many. Talk them. Talk number.
No. Coach rep, you drop your number rather so that no drop your number so that they'll WhatsApp you. So that you can send them the link to join.
Simple as ABCD.
Yeah, so you rather drop your number so that they will copy it and WhatsApp you.
No, even that one will be tedious. It will be better you drop the
Yes,
link so that
yes.
we
You
access
drop
the
your
link.
number so that they will take it and WhatsApp you right now.
You can send the number on this platform.
Now that I've realized the reason why maths, our lesson is hardly finished. We talk a lot. They will give you 2 hours to go and deliver a lesson. Someone's lesson. Also, the two microphones.
Lamba. Want to fight? Fight.
Yep. Please, you can the group, okay? Please, you guys can leave the group, okay?
Hello, please. Are we on break?
Yeah, but we'll be meeting. Oh, yeah. So,
Please, I'm listening.
yeah, the whole thing is that okay, currently the lecturer is not feeling well. Okay, so she's going to arrange a new class with you.
Oh, okay.
Yeah. So, you, if anything, we will let you know. Okay, we are
Oh,
going to
okay.
arrange for you guys.
Thank you.
But I don't know how you tell your colleagues to, yeah, visit the group. Yeah,
Oh,
we are
okay.
done for now. Okay,
We'll let them know. Okay. Thank you.
you're welcome.